Hello and welcome everyone. Today in this video we are going to be looking at basic input-output in R. What that means is how you're going to read in data from files, how we are going to save R objects and data to files, and also on the output side how to print information to the screen, to the output. This is really useful if you want to use R to generate automatic reports resulting from data analyses. All right, so there's a file here. It's called input-output.r. That's the one we'll be going through today. And so let me fire up R. Okay, so we have our file on the left and an R session on the right. So R is designed for data analysis. So it has many different tools for working with data, for reading data, for writing data, and of course for manipulating data and doing analyses. Probably the ones you've come into contact with so far are the read dot functions. So this includes read.table and read.csv. So let's actually run read the documentation for read.table. So in this documentation file, it documents read.table, read.csv, read.csv2, read.dlim, and read.dlim2. So these are all files for, obviously, for reading data from files, functions for reading data from files. They're all going to have a file argument, and then they'll differ in how they actually implement that. So read.table, I guess, is the most has the most options, although most of these options can be arguments can be fed into the other files, the other functions as well. So the main difference between read.table and read.csv is read.csv automatically sets the separator to a column, to a comma. So what this is, so the function is called read.table. So this is designed for reading in rectangular data structures, meaning like tables of data. And when you look at files like this, and we'll look at one in a second, basically you have to, in the file somehow, you have to tell it when the next column of the table starts. And so by default in read.table, it's the empty string. And the default in CSV, comma separated, is a comma. So we often use read.csv in this class because I like to save things as CSV. Okay, so let's see this in action. And let's look at this file first. So I have a file here called marathonwomen.csv. Let me open that up. So it's in datasets. Marathonwomen.csv. And okay, so here's the file. The first row is contains the column names for this table. And then each individual line in the file is a specific performance in a marathon from a specific runner. And then, so it starts with some name information. Each of these is separated by a comma. And then it has the year, the date, the time, and some other information here. So let's get back to our R session. And so we're going to use read.table to read that in. We're telling it that it has a header. That's that first row with the column names. And we're telling it what character is used to separate the different columns. So that should work fine. This by default will read it into a data frame, which is of course a special type of list. And we'll use head just to print out the top of it. So if you remember from looking at the file, the first non-header row was Caroline Rotich. Okay, so that does that. Read.csv, like I said, is very similar. It sets some of the, it's sort of like, it's just like read.table, but it sets some of the arguments to default values. specifically header true and sep equals comma. So this should do the exact same thing. Now there are tidyverse alternatives to these functions. They can be found in the readR package. So read_CSV is the analogous function to read.csv. So if I run that, it's printing out some information here, and that's reminding me that read_CSV is reading to a tibble. If I type dat, there's all this extra information here, which is very useful. And head does the same thing. Now these functions, read.table, read.csv, read.csv, they assume that your file is nice with no missing columns and some rows and things like that. Now, if you have kind of messy data, there are lower level functions, scan and read lines, that give you a bit more control over reading in files line by line. So take a look at those if you have some kind of nasty files. All right, so like MATLAB and other data heavy languages, R has its own data formats. The one you've definitely seen is .rdata, and there's another one called RDS, which is similar but a bit different. And so let's go through the difference between them. So you've probably used load. So load is used to read in a .rdata file format. These are our data formats that were saved with the save function, and we'll look at that later below. One thing to remember when using load to read in an RData file is that there's no assignment operation. So let's see how that works. So we'll run ls. ls tells us that there's a single object in our workspace called dat. And when we call load on an RData file, so this is a RData file that I saved. It's a very simple thing. It's just a list. It doesn't print anything out, but if you run ls again, you'll see that there's another object now available called mylist. And there's the list. So this is a bit different than how most R functions work, in that an object becomes available to you upon calling this function without doing an assignment. So this is a little bit different from what we've seen so far. So one nice feature about R data files is that they can hold multiple objects, whereas we'll see below RDS only holds a single object. So I have another R data file called multiple objects, and if I run that and ls again, you see now that there are 3 more objects just called obj1, obj2, and obj3. And we can look at what those are. That's a vector, that's a matrix, and that's a function. And of course, we still have mylist available. Now, the other RData format is called RDS. So I have an RDS file saved in datasets. So if I run info RDS, this gives some information about the file that was saved. It doesn't tell us what the contents of the data are. To read in an RDS file, we use read capital RDS. And here we do make an assignment. So this will get assigned to my underscore list, whereas the other one was called my list. So main difference here is that you can only do a single object with RDS, and when you call readRDS, you have to make an assignment to a specific object. I think that in my experience, the load, so the RData file format, is much more popular than RDS. But I personally consider RDS to be a nicer, safer option, because if you have something in your code that just says load, it doesn't, looking at the code doesn't tell you what objects get added to your workspace. So this can be a bit dangerous. Whereas RDS, there's explicitly, you're reading this thing and you're assigning it to this object myList. So this is a bit safer. You know exactly what's happening in this line when you look at the code. And it operates, like other R functions that return a value that you have to assign to an object. So I have a personal preference for this one, but I think that RData is much more popular. Another important feature of these R data formats is that they use compression to reduce file sizes. So let's take a look here. So what I want to do is show you the file sizes for two files that contain the same information. So I've saved this Marathon Women data set as an R data file, and I also have it as a CSV. These two files contain the same information, but when we saved it with the save function, which we'll see below in a few minutes, R does compression on the object so the file sizes can be smaller. So let's take a look. Data sets. So marathonwomen.csv is 102,000 bytes, whereas marathonwomen.rdata is only 17,000. So this is much smaller by about a factor of 6. And that's because R is doing compression to save the object with the RData file format. Okay, so that's something to remember, that compression can make your file smaller. Okay, let's take a look at this. So this read in that marathonwomen.rdata file, and the name of the, so one way to check what the name of the object is to look at the variables in the workspace before and after reading it in, and then printing out the differences. So that's called dat.rdata. And this is just to show you that it's the same object. I'm just printing out the head. Okay. So those are various ways to take data from a file and bring it into R. So that's the input side. And now let's look at the output side. And we're going to both look at printing things to the screen and also saving files. And we're going to start with printing things to the screen. So the easiest way to produce output in R is with the print function. So remember, we have an object called myList. So if I call print myList, it will print that object's contents to the screen. And different types of objects have different type of print formatting. We'll look at examples of that in a second. But this is how lists get printed. If it's a name list, it'll say something like $, then the name, and then it'll show the object here. So we have $vec here, 1, 2, 3, 4. Also, if we just type the object name into the console and run it, it does the same thing. So what's happening here is nothing really happens on this line. So there's no assignment made, no function calls. But what is actually happening behind the scenes is R is calling print with this object as its argument, and that's getting printed to the screen. So the function print is used to print things to the screen. And this works most of the time, but there are some few exceptions. So if you're inside of a loop or a function and you just have the object name here, it's not going to print it. Here's a function that just puts myList here and returns null. If I do this and I run the function, assign it to an object, nothing gets printed, even though this looks like it should get printed just like it was printed up here. Since it's inside a function, it does not get printed. So that's something to remember. Now, if you want something to get printed inside of a loop or a function, just put it inside of the print function, and this will print it. Well, it's a loop from j equals 1 to 3, so it prints it 3 times. Same thing for functions. If I call that function, it prints it out. Okay, here's a little quiz for yourself. I'm calling this function print something, and this is the function definition. If I run this, you'll see that what I said before doesn't quite hold up. If I run this function, the list does get printed out. Okay, so to quiz yourself, try to figure out why something does get printed out in this case, but it does not get printed out in this case. Now, this print function is pretty versatile in that it has different rules for how to print out the object depending on what type of object it is. You'll see over here, if it's a list, it prints out the names and then each list element. But if you print, I don't know, for example, my list $vec, you just get like a 1 here to indicate the first element and then the element names. If you print my list $mat, it gives you the row numbers and the column numbers here in addition to the contents of the matrix. So the way R handles different types of object is because the way it does is it makes print something called a generic function. So if I run this line, what's going to happen is it's going to print out the function print. And you can see that there's not a lot of information here. It just says use method print. This is an example of what's called a generic function in R. And we'll get a little practice with this in just a second. Okay. Let's look at the documentation for print. So we can see here that print prints its argument and returns it invisibly via invisible x. It's a generic function, which means that new printing methods can easily be added for new classes. Okay, so there's not a lot of information here. To get documentation about individual print functions, you could type print $, and I'm just hitting tab here. See, there's a whole bunch of these print functions. So if it's a function, what gets called is print.function. So print, so I'll do print my list $fun, I think it was called. That prints that function. This is doing the same thing as print.function my list $fun. And then if you want to see the documentation for print.function, you type it in directly. And this just maps back to the generic print. So there's really no documentation for the specific print.function function. Let's do a quick digression to see how these generic functions work. So print is a function that uses one of R's 3 object-oriented programming systems. The system is called S3. There are actually 2 other object-oriented programming systems in R. S3 is the simplest to implement and least strict. So to use the S3 object-oriented programming system, well, all we have to do is define a method for a class and a generic function. The class is defined as soon as the method is defined. So this is how it works. It's very simple. I just define a function called print.diagmat. So here's a function. What this function is doing is it's taking in a vector D, and it's printing a diagonal matrix with D on the diagonal. And now this diagmat class is defined because we have a method for it, print.diagmat. And let's see how this works. So I'm going to define D. This is just a plain old atomic integer vector. If I look at its class, it's an integer vector. And if I do print D, it does the normal printing that you expect for atomic vector. Now, if I change the class of D to diagmat, and I call the generic function print with D as the argument, what R is going to do is it's going to look at the class of D, which is now diagmat, and it's going to call the function print.diagmat of D. So let's see this. So this is printing out a diagonal matrix. D, yeah, and if I call D now, what happens is R calls print on D, and then it sees that D has class diagmat, and then it calls print.diagmat. So this is something that's used by a lot of R packages and functions, these generic functions. This is just a very quick introduction for how these work. But as you can see, it's actually pretty simple. For a nicer example of printing sparse matrices, so a diagonal matrix is an example of a sparse matrix, which is a matrix which has a lot of zeros. The matrix package with a capital M is a whole big R package designed to handle sparse matrices. And there are functions like capital diagonal for defining a sparse matrix. So this defines a sparse matrix and then prints it out. And you can see it does these nice little dots, so your attention is drawn to the non-zero entries. Okay, so the print function is very flexible because it's a generic function. You can define your own classes and methods for it. But most of the time, you don't really want to go through all that trouble. So there are other ways to control how objects get printed out in R. One of the ones that you'll be using often, and I use very often, is called cat. So let's look at the documentation for cat. So cat is short for concatenate and print. And its description says it outputs the objects concatenating the representations. Cat performs much less conversion than print. So the way you use it is you give it some objects here. There's an optional argument called file if you want to print to a file instead of to the console. And then there are some other arguments as well. So let's see how this works. Here I'm giving cat a string, character vector. Hello darkness, my old friend. So what happens here is to the console, it literally just prints out that string. So this is different from print. If I were to, let's actually do print here. It does this thing where it prints a 1 in front to tell us that it's a vector, and then it prints the contents. So cat doesn't, it's just kind of more literal. And it also includes the quotes when you use print. The other benefit of cat is it can handle these special characters. One of them is the new line character. So if you do /n, that's a new line. So what happens here is it actually does the return at the end, whereas this one does not. You can see how the console is over to the right. And then you can put multiple new lines in to format things. So, hello darkness, my old friend, I've come to talk with you again. Puts that on 2 lines. If I want to put some white space around it, I can do a new line at the beginning and then 2 new lines at the end. You can see how it differs here. So cat gives you a lot of flexibility in how character strings get printed to the console. Doesn't use the quotes, and it recognizes these special characters. This is just to show you what happens if you put it into print. So print adds the quotes, and it does not recognize these special characters. Okay. Now, cat is often combined with other functions. So here we're giving cat just the character string we want to print out. But in many cases, you'll want to sort of use some other function to combine strings together or make them look a certain way, and then pass that to cat to print it out. All right, so let's see. The first example of such a function is called paste. Let's look at the documentation. Okay, so paste concatenates vectors after converting to character. So the arguments are one or more R objects to be converted to character vectors. It has an argument called sep. So if you paste two character vectors together, paste allows you to say what you want to put between them. That's the sep argument. By default, it's just a space. There's another function called paste 0, which automatically sets sep to an empty string, so there'd be no space between them. And then let's see here. Value is, so this is what gets returned by paste. What gets returned by paste is a character vector of the concatenated values. So the thing to remember is that paste itself does not print things to the screen. Paste is used to create the character vector that you would pass to either print or to cat. All right, so let's see this in action. All right, so I'm defining a first name Joe, last name Montana, the famous 49ers quarterback. And if I do paste first last, it's going to concatenate Joe with Montana and separate it with a space. And you can see that happens over here. Now I put a little comment here. Make sure you understand what's happening on this line, because I just told you that paste doesn't print things to the screen. So what the heck is happening here? Because it did print something to the screen. So we're not doing an assignment of this. So this is creating a character vector, and we're not assigning it to anything. Therefore, what R does is it calls print on that thing and then prints it to the screen. Just like if you typed in any old vector, it prints it to the screen, even though the C function is not a function for printing to the screen. Okay. Paste 0, like I said, puts them together but without a space. You can see that on the right. You can have more than two things that you paste together. So this is going to explicitly use paste 0 to do the first name, add a space, and then do the last name. And if you use paste, it has this sep argument. So if I wanted to do Montana, comma Joe, I would do last, first, sep equals, comma space. Okay. Now to print things to the screen in a way that you like, you can combine paste with cat. So here I'm doing first, last, and then a new line, and then I'm passing that to cat. So that does Joe Montana without quotes, and then it interprets the new line for a return. Cat, even though cat is designed to print things to the screen, it does return something. It returns null, just in case you need that. And then paste and cat, paste in particular, is able to take in vectors as their argument. So let's see how that works here. So I'm going to define 3 first names, Joe, Hannah, and Tony. And these people all happen to have the same last name, Montana. And if I do paste first last, what it's going to do is it's going to paste Joe to Montana in the first element, Hannah to Montana in the second, and Tony to Montana in the third. You can see that here. Now this is a vector of length 3. And R also uses recycling and paste. So they all have the same last name, so we can just define a single last name. And if we do paste, so let's recall, first is vector of length 3. Now last is a vector of length 1. And if we do paste first last, it's going to recycle the shorter one to match the longer one. And it's going to do Montana on each of them. And then we can cat them. So if you put a vector into cat, it just prints them out one by one, separated by spaces. This adds new lines. Recall that, so what's happening here is it's creating the vector, and then print is automatically getting called to put it on the screen. And print does not recognize the new line characters. So I have to pass that to cat to get it to recognize them. And that's what I want to see. Now paste is just one function for creating character vectors, character strings. There's another function called sprintf, which gives you a little bit finer control for how things like numbers are printed out. So let's look at the documentation for sprintf. Sprintf is a wrapper for the C function of the same name that returns a character vector containing a formatted combination of text and variable values. So importantly, sprintf returns a character vector. So if you're familiar with the C function sprintf, this is all going to be familiar to you. If not, there's a bit of formatting to learn about. So the first argument to sprintf is a format character string, character vector. And then after that are R objects or values to be passed to format. So let's see how this works if that's completely foreign to you. So let's get back to Joe Montana. The way this formatting works is we have these special characters. So %s stands for string. So here I have 2 %s's and then a new line. And basically we're telling sprintf that we're going to pass 2 variables that are both character strings. And what I want this function to do is put the first one here and then a space, and the second one here, and then do a new line. So if I called this with first and last as the 2 character strings, Joe and Montana, that's what I get. I get the first one, Joe, and then a space, and then Montana, and then a new line. If I do multiple spaces, I get bigger spaces. You can pass to these special characters, you can tell it how much room you want to set aside for each character string. So here I'm saying I want to set aside 10 spaces for the first one and then 8 for the second one. So what that does is I think it counts from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And Montana has 7 characters, so it just puts a single space. So you can see that there's a space here because we specified 8s, even though we didn't put a space between the 10s and the 8s. And of course, if we put a 10s in the second one, we're going to get spaces between the two. So this is really, really useful if you want to generate a report that has like a table of data and you want to make sure that the columns of the table line up properly. Okay. Now, just to see a few more examples. So we looked at %s for character strings. You can also do %d for integers, and then we're going to look below at %f for floats. So I'm going to define 2 new variables, num and team. And what I want to print out is Joe Montana won 4 Super Bowl titles with the San Francisco 49ers, period, new line. So I do %s for Joe Montana, 1 %d for the 4. Super Bowl titles with the %S, which is San Francisco 49ers. So that does that. And if I wrap it in cat, it actually cats out that string. So it gets rid of the quotes and then puts a new line at the end. The other special one is %F. This is for handling non-integer numbers, doubles or floats. So I'm going to define % as 62.7. What I want to write is Joe Montana completed 62.7% of his passes. So my first attempt of that is I'm going to do %S for Joe Montana, completed %F for 62.7, and then a % for %, and then of his passes new line. So what happens here is I get an error, too few arguments. The culprit is this second % thing. This is kind of a special character in the sprintf format. And to actually get the literal % sign, I have to do a double % here. So see what this does is Joe Montana completed 62.70000. So this is probably not what we want. So to control how many decimals get printed out, we can pass numbers to this %F. So if I do %4.1F, it's going to reserve 4 spaces for the 62, and then it's going to do a point and 1 space for the 0.7. If I want to do 2 spaces, so 62.70, I'll do 4.2. And if I want to reserve more space on the left side, I could do %5. That'll put another space there. Now sprintf will accept vectors as well, and it will do recycling on those vectors. So let's look at our Joe, Hannah, Tony, Montana example. First, last. If I do %S new line first, it does Joe, new line, Hannah, new line, Tony, new line, and it keeps this in a length 3 vector. If I pass that to cat, it does Joe, Tony, Hannah. That means that cat can actually take in a length 3 vector, and it basically just puts them together. It does recycling, so if I do %S new line, first was a length 3 vector and last was a length 1 vector, it does what you expect it to. It recycles the last name, and then cat will print them out. Now, one last thing, there's an additional argument to paste called collapse. So paste can return a vector of character strings, but if you want to take that vector of character strings and put them into a length 1 character vector, you can invoke the collapse argument and tell it how you want to collapse them together, meaning what do you want to put between them when you collapse them into one vector. So let's look at this. This is Joe, Hannah, Tony, Montana. And if I pass this into paste, so this is a length 3 vector, and I invoke collapse, it's going to take that length 3 vector and put it into one character vector, but separate each element by space, pipe, pipe, space. So that does this. This is also, again, very useful for creating nice looking tables. Okay, so we've done input, and we've done the first half of output, which is outputting things to the screen. Now we're going to do the second part of output, which is writing things to files. So the first thing I'm going to do, just so we have something to write, is read in this marathon women.csv. And let's look at that. So that's the data set we looked at before. And I'm also going to read in a data set of men's marathon times. I'll call that dat men. And what I want to do here is I want to create a single data file that has both the men's and the women's time, but I'm going to add a column for the sex of the athlete. So I'm going to take .women $sex and set it to female, and .men $sex, set it to male. And then I'm going to use the rbind function to bind these two data frames together, .women and .men. And if we do head .both, it's just going to show the same women's one, but you'll see that now that there's an additional column called sex. Okay, I want to write this to a CSV file, and conveniently there's a function called write.csv. It can take in a data frame as its argument and a file name. So this will write it. What I want to do though is look at the file. Let's see, we put it in datasets, marathon, both. So this has some undesirable properties. Most likely you don't want row names. So what it does by default is it has an additional column with no column header, just an empty string, and then it assigns a row number to each one. That's really not all that useful. So let's look at how to get rid of that. Okay, we can look at the documentation, and we see it has a optional argument called row.names, and its default value is true. So what we're going to want to do is override that default argument, set it to false, and let's look again at that file. Changed on disk. Yes, I want to reread it. Okay, now you can see, I'm not going to put it onto one screen, but now you can see though that there's no row names, which is probably what we want. Okay, so that's write.csv. That's how to get rid of the row names. That's for writing things like data frames to a file, because we know it's going to be a nice rectangular object. Now, if you want to kind of just generically write output from your R session to a file, there's a function called sync. And sync has a single argument, a file name. Actually, it may have more arguments, but this is the required argument. So I'm going to say, what file do I want to write to? And then I'm going to do some operations which produce output. And then I'm going to call sync again, which will stop printing it out. So let's run this. As you see here, when I'm running these things, which normally produce output in the R console, they're not. They're getting written to this file, output.txt. Cat some more things. Create a vector, print it out, call sync again. And just to show you that it stopped, I'm going to run X, and this now prints it to the console. So let's look at that file. So everything that happened here that would have gotten printed to the console is now printed to this file, output.txt. Okay, let's get rid of that because we really don't need that file. Next thing we'll look at is saving R objects in the R data format. We've already read in these files with load and readRDS, and here we're going to show you how to save them with the save function, as promised. Okay, so let's make a list. Here, this is the list we looked at before. I'm calling it my list. It's got a vector, a matrix, and a function in it. We can look at that object, my list. That's the one we saw before. And to save it, it's very simple. We just call the save function. We put the object that we want to save, and argument called file, which tells us which file we want to save it to. And so that's saved a file. We can remove the object myList. Now it's gone. And to restore it, I call load on that file name, datasets mylist.rdata. And it loaded it back in, and now it's available to us. Okay. As I mentioned before, these RData file formats allow you to save multiple objects together. So let's see how that works. I'm just going to create some objects. These are actually the same objects that are in my list, but they're separate objects. Vector matrix function. And then I'm going to, just to show you it's something different, I'm going to modify the function in my list to subtract off x from x squared. As you saw before, it was just x squared before. And then I can save all of these in one go by just listing them out between commas and then putting the file name. Here I'm calling it multipleobjects.rdata. Now I'm going to remove them just to show you that they're gone. You won't find obj1, obj2, obj3, or mylist there. And then I'm going to load them back in with the load function and print out all the objects. And now you see here obj1, obj2, obj3, and mylist should be somewhere among these. There it is. Okay, and then the other RData file format is RDS. This works the same way as save, but it's saveRDS, and I can only put a single object in here, my list. So that's that. And yeah, when we read it in, we'll use readRDS, and remember we have to assign it to an object name, so it won't automatically be called mylist. Whereas when you read in with load, it preserves these object names. Okay. I mentioned before that these things do compression to reduce file sizes. We already looked at before, so I won't pull it up again. But just to remind you, this object that we're saving, .rdata, using the RData file format, was about 6 times smaller than the corresponding text-based CSV file. Okay, so that's your video on input-output in R. See you next time.